Welcome back to yet another beautiful, sunny and warm day in Thailand. Are you frozen people tired of hearing this yet? Anyway, our goal for today is to go ahead with the strategy of adjusting the inputs for the voltage and current, and that means also moving the UART to USB chip. So the end goal is to split the current and voltage up into the two different ADC controls and move the USART onto the remaining unused pins. This is going to make things simpler in software, hopefully get us more accurate readings. It is going to change the circuit board, so I'm going to have to start cutting and running jumpers. But that's the price you take when you play with hardware, because in software you just change the code and save it and recompile. In hardware you get to change the wires. Okay, after analyzing the pinouts and then setting it up in Atmel START, our old pin 11 is PA08, is SIRCOM 0, pad 0. That changes to pad 2, so pad 0 and 1 change to 2 and 3. SIRCOM 0 pad 2 is PA10 is pin 13. That's the receive pin. Pin 12 maps through here to pin 14. But when I went to set up this new arrangement in Atmel START, it wouldn't let me select pin 10 and then pin 11. If I selected pin 10, pin 11 was not an available choice. The only way I got it to work was select pin PA11 for receive, and then PA10 showed up for transmit. So instead of being pin 13 and 14, it's now pin 14 and 13. God, I hope this works. All these limitations you never find out unless you try and set up the software or write some code. So let's see what that looks like on the circuit board. Okay, if that's the plan, changing things in software means changing things in hardware too. So I'm going to be cutting and jumpering a few things around the top of the board. These are mostly power signals. So what I need is very, very small jumper wires. So I looked through my box of goodies and I found these prototyping board jumpers, which are pretty small, but if you compare it to where I have to jumper onto a pin on there, it's a little big. I've got these resistors. Still, that's a little better. Still a little big. I've got 1/8 watt resistors. They could do in a pinch, but they're still a little big. And then I tried the actual jumpers for breadboards, and I tried to strip off the insulation to see what's inside there, but these things, it just doesn't want to strip. It just breaks. No matter how I tried, it just snapped off. So these are not suitable. So I thought I'd have to go with the 1/8 watt resistor, and then I remembered I had a bunch of these jumper wires that I bought to replace what I thought was the broken wire on the debug header. So I sacrificed one to the gods, and even though it's a multi-stranded wire, focus you fac, it's a multi-stranded wire inside, it twists up pretty well and it's very small, and I think it's going to do the job for us because it's actually smaller than the physical pin that it's going to be soldered to. I really wish I had some of that small enamel wire that Louis Rossmann uses, but I cannot magically make that happen in a very short period of time. So the first thing I'm going to do is move the USB wires and change Atmel setup for the USB and make sure that I'm still writing to the USB port. So let's try that. Okay, so my camera has a terrible macro lens, but you can see what I changed here. Luckily the pins are very close. So what was on pin 9, 10, 11 changes to 14, which is there, and what was on pin 12 just moves over one pin to 13. And you can see that actually improves my circuit board layout because I don't need to jumper underneath to flip-flop these pins. They're going to go straight from the USB straight across the top and in. So let's run it and see if we get our communications. Okay, I powered it up and nothing. I couldn't get a single character to flow through the terminal. So I thought, maybe I should switch the receive and transmit wires. So I went back to the circuit board, and you can see, maybe barely, that all I did was, where's my thing? I moved pin 11 down 2 to 13, and I moved 12 down to 14. You see, I had to go back to my jumping over the back of the board, and look what happens. If I can get my cursor back here. There we are. So the start tool has things backwards to the way the chip needs to be wired to successfully work. When you use pads 2 and 3 on SIRCOM 0, it's backwards. Thanks, guys. Okay, after that success with the USB port and the LEDs that I did on a separate video, we're going to go back and change our current sense input. And that's going to go on ADC1. I've deleted everything to do with the ADCs, so we're going to start from scratch. We want an ADC, which is down at the bottom right here. I'm going to add one. Click on it. It is an asynchronous ADC, and our instance is ADC1. And we're going to go for analog input 10 on PA08. We're not going to do anything with analog input 11. We're leaving all of this stuff as it was. Actually, the reference is going to be VDD analog, yes. Because we want to refer this to the 5-volt signal that's running on the rest of the board. Clock's okay. We're not in differential mode. Positive mux ADC A in 10. Again, why did I bother setting that here? And then we're going against IO ground. This is what I need for my configuration. Asynchronous driver on ADC1, A in 10 is on PA08, which maps to pin 11 on my chip. Full 12-bit scale, refer to VDD analog, not free running, not differential, positive mux, ADC A in 10, negative mux ground. Good, let's generate this puppy. Now I'm going to go through my code, uncomment anything to do with the ADC that I had commented before to avoid compiler problems. Then I'm going to change all the comments in the code to refer to ADC1, similar to this issue right here. And let me do that, and then we'll come back. Okay, I've done the jumper change. The output pin of the ACS 770 snakes through this little gray wire and hits pin 11 on the C21. That's pin 9, 10, 11. And you can see these two are left alone for the USB. So it's really horrible. You can see I had to kind of go through the air to get there. But we'll see if it works reasonably in software now. Okay, code is running. We're getting a slight offset in amps. Coming over here, turn on the 12 volts. Current check. Lights on, 4.2 amps. Come over here, 3.6, 3.4, 3.4, 3.5. So the input's working, minus all the calibration issues I've got. But I managed to get the analog input working single-ended on ADC 1 on pin 11 of the chip. And that is enough for today. Tomorrow I'll attack the differential on ADC 0. As you stare out on my beach, I would ask you to subscribe to my channel and click like on this video so YouTube thinks I'm worthy again, and I have so many people on my channel that they'll give me 10 cents a day in ad revenue. So I thank you for that.